Good evening, all. We would like to welcome Dr. K. Sudhendran to handle the session on AI in stormwater management systems. Dr. K. Sudhendran is currently associated with the Department of Information Technology as professor at Kalasalingam Academy of Research and Education, Krishnankoil, Tamil Nadu. Basically, he is an electronics and communication engineer, completed his BE ECE from Madurai Kamaraj University with first class with distinction in 2002. Later in the year 2006, he had completed his ME Communication Systems from Anna University with first class with distinction, and he has gained his research experience in wireless communication systems, obtained his PhD from Kalasalingam University. In total, he has 22 plus years of professional experience, including both industry and teaching. In addition to his current position, he has also played many administrative roles like head cyber forensics research laboratory for more than 9 years, head of information technology for 3 years. So far, 7 of his research scholars have completed PhD under his guidance and 8 more are pursuing their PhD. He has completed 1 funding projects from DST, published 97 research articles, 5 industrial design patents, and 1 granted patent. He also co-authored 3 textbooks. As a resource person, he has handled 40 plus sessions of cyber forensics and AI across the country. He is a member of IEI. Thank you. Welcome you, sir. Sir, kindly unmute the mic, sir.
Yeah, thank you very much. I take this opportunity to thank Madanapalli Institute of Technology and Science for giving me this opportunity to handle ATAL FDP titled AI in Stormwater Management System. I personally thank Dr. Murugan for communicating with me for the past 10 days related to this event. In fact, it is a learning opportunity for me because while preparing for this session, I happened to observe many one minute, let me share my screen. Yeah. So the preparation actually opened up many research problems in stormwater management system. So for that, I personally thank Dr. Murugan and the Madanapalli Institute of Technology and Science. I hope you are aware about this stormwater dynamics. Water, we all know, stormwater, it is actually excess water from rain. When snow melts, we get some excess water, and while watering the agricultural fields, there also we get some excess water. All these excess water goes to water bodies like lakes, rivers, ponds, and finally it reaches the sea. The point here is the water from rain actually the water droplets before reaching the ground, it will be in the pure form. Once it reaches the land, so based on the place where it is reaching, it may get contaminated. So once the water gets contaminated, there may be the chance for creating impact on the aquatic life, and the water may not be in a usable condition. So by having a proper management system, we can collect water, rainwater, and this snow melting water, and even agricultural water. So if there is a system in place, we can collect the water in usable condition. That is the one line information. So our Indian government has taken many initiatives to harvest the rainwater. Many of the buildings are these days having rainwater harvesting. So it is our responsibility to make sure that all the uh, water collecting bays are in clean, so that whenever rainwater comes, it may get collected in you know quality manner, right? So that's about this stormwater management system. So there are system in practice. Many industries, research laboratories are working, and some companies even they are offering a software solution to manage the storm water in some countries. And while seeing this title, I got some my childhood memory that we all would have gone through that poem, "Rain, Rain, Go Away." Right now, the condition is we can say whether rain, rain, go away or stay. Whether rain, rain, go away or stay. Data tells all whether rain will go away or stay, right? So that is the condition. So many places people are using trained models to predict when rain will come, when rain will go, everything. So with the basic information, let's get into the session. Uh, Sir has given enough intro about me. Yeah, so I'm skipping my intro. Right. So this session I'm going to cover uh, in four parts. One is AI reshaping our world. So these days we are hearing news about AI every day, every minute. We are hearing new news, starting from creating content, creating voice, creating images, creating videos. So almost all the work done by human except getting married and giving birth to a child, everything is now possible with AI system. So that is the scenario. So the world is actually uh, you know changing towards artificial intelligence based solutions. So let's see what are all the things are happening in different domains, and what impact it is creating. And the other topic is about like the future of research powered by AI. Many people are now incorporating AI based solutions in research. So they are making all kind of research and getting results in faster manner and better manner, in quality manner. right? So we'll also uh, discuss about those things. And the third thing is I got an opportunity to play with the data set. Actually, I'm not expert in water management, but uh, we are getting data. We are getting data. So if data is available, we can train the model, and we can analyze the data. By using the data, we can predict what is going to happen in near future. If we have temperature data of a particular snow uh, uh, snow point, then we can predict when snow water will come, or when snow water may not come, those kind of things. So I will be sharing those the play what I did with available data sets and what kind of graphs I have generated. So we'll look into that. And finally, the a new era in stormwater management. The industry who are actually involving in stormwater management, and what kind of practices they are following, and what they are aiming for. So those kind of things also we will cover, right? So with this intro, we'll begin with reshaping our world with AI, right? When this AI came into the picture, we may be wondering, this idea was the outcome of one workshop. Okay, in 1956, uh, in USA, at Dartmouth conference was happened. So these 10 people, many of you may be knowing John McCarthy, computer science scientist, and Marvin Minsky, and Claude Shannon is the father of information theory, right? So these 10 peoples actually joined, and they organized a conference. In the conference, they conducted a three week long workshop in which they came up with an idea. Why can't we make the machine to learn? After making the machine to learn by asking uh, the required things to the machine, we can get the answers. Okay, so that idea actually they got in 1956. So these 10 people are called as the founding fathers of artificial intelligence. Uh, yeah, this shows the dimensions of Dartmouth conference. Uh, the organizers of the conference is John McCarthy, Minsky, and Rochester Cloud Shannon. These people organized the event during the summer 1956 at Hampshire, United States. And the goal was to simulate human intelligence, uh, giving human intelligence to the machines. So that was the goal of their conference, I mean the workshop. And the workshop covered the topics like natural language programming, problem solving, learning, and neural network. Okay. So this was the dimension of that conference. And the actual birth of artificial intelligence happened during 1956 through this Dartmouth conference. They conducted a workshop, and that resulted the birth for artificial intelligence. So from that day onwards, people started working on that idea, and slowly, then during 2000, people came with uh, 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 modeled machines like ChatGPT, right? Actually, IBM was the front runner who is taking this idea to the next level. Okay, then many industries join together. Okay, right. So why this AI is now everywhere and attracting every field? In fact, our Indian government, the ministry, MHRD, along with Ministry of Education, has given a call for proposal to set up a center of excellence in artificial intelligence. In the health related things. So if kind of medical documents like images, so by giving those images to the machine, machine will tell its prediction, what possible disease the person is having or going to get. So we no need to go and stand in the hospital for a day and to meet the doctor and get the diagnosis opinion. We can get some sort of prior uh, information from these models. And the third one is for sustainable cities. So all these three centers going to get 300 crore rupees funding. In fact, this in 2023 budget. So based on that, that call happened during last Jan with the condition that only the 100 NIRF ranking institutions are eligible to apply for this proposal. So many institutions, they separately and joined with different groups, different companies. They have filed the submission. Now the scrutiny is going on. After this scrutiny, they are going to identify 15 best proposal. All the 15 will get 2 crore initial funding. They give 6 months time. Based on their performance, they will choose 3 centers. Those 3 centers are going to get 300 rupees, I mean 300 crore rupees for establishing this center of excellence. So it is also happening in other countries. In fact, our Indian government has also come up with setting this kind of center of excellence using artificial intelligence. Right. Something I come across through the news channels. This photo shows the Hollywood writers battle against AI. Humans win for now. The point is, these people are actually the, the script writers for the film industry. They used to write script, so how the flow of films should be. Okay, so what happened is many producers started using AI for generating the script. So all these people got affected because they are not getting their job. So they made a battle for 148-day strike against AI, and finally some kind of compromise happened between these script writers and other workers with producers. This is not only with content. You might have heard about there was some news sometimes ago in some Telugu movie. SPB Balasubramaniam voice was mimicked by AI without the permission of SPB family, and they filed a case. So the idea is, whatever we do, if we make the machine to learn, the machine will repeat. In fact, if I give 30 seconds of my voice to the machine will learn my voice. After that, if I'm giving some content, the machine will start reading the content in my own voice. So I no need to present and deliver the lecture. Instead, I can train my voice to the machine, and machine will mimic my voice simply I have to give the text what I supposed to deliver. It's not only with the content voice. If you want to generate a music, there are artificial intelligence tools which creates music for making your PowerPoint or some kind of presentation. You can incorporate background music with help of AI. And if you tell some situation to the AI will write lyric for you. Think about the the position of lyrics. If AI is generating lyrics, then who will approach them? So, so in all the fields, there are around some 2000 AI tools are available as of now, as far as my knowledge. Each tool is performing different tasks and making our 3 hours, 4 hours work to get complete in 2 minutes, 3 minutes, even a single click. Many of the tools are free as of now, and some features are demanding pay. So it's like many people are now giving their tool for free. The reason is they are making their model to get trained with more information. So once their model becomes good, then they will charge surely. As like how we are charging our mobile phone every month. In the same way, in near future, all will uh, renew our AI tools monthly. That is going to happen because the work, whatever work we are thinking that we can make fast, fast time in better way. Okay, so that is the scenario. And this is about one news in United States Patent Office. One application, surprisingly, they have included AI as one of the inventor. But as per Patent Act, the inventor should be a natural person. Inventor cannot be a machine. Okay, so they have United States Patent Office. They have refused. No, we cannot include artificial intelligence system as one of the inventor. Then this matter was taken to the court, and court also, uh, stay back with the Patent Act, because Patent Act is actually formed by government, so no one have rights to change or modify. So we have to follow the act. That's it. And this is about the news. Canadian news companies challenge OpenAI over alleged copyright breaches. The OpenAI, what they're doing is they're taking all the data which is available in the internet, and they're using that data to train the model. So whoever uses that trained model by asking different questions, they can get the even confidential information as well. So, 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 so for this reason, the Canadian news companies filed a case against OpenAI as well. The future of research powered by AI, it's like you see these two pictures. One on the left was actually taken by a satellite about the flooding, future flooding in a particular location. And the right hand side is the picture generated by AI tool. The idea is by using AI tool, we can make the we can enhance the image. We we can remove the noises, we can improve the quality, we can all sort of operations can be done with images. Okay. So this is also attracting many research these days. Many people are working with images, in particular in medical domain. People are taking noisy images. The whenever the low radiation based images, I mean for CT, MRI, X-ray, for all these scans, people are passing some rays on the human, and they are observing, I mean, they are capturing the uh, actual status of a person. But the study has proved that the excess ray also will, excess rays may also cause kind of cancer. So now people are started moving towards using low radiation. If we use low radiation, the problem is we may not get quality image. Then we can make the models. I mean, we can train the models to remove the poor quality images to the quality one. So that is the one kind of research which is attracting many researchers in and around the world. And this is about a product which used to prevent the flooding. Okay, so with the help of sensors, they can sense the real-time data, I mean real-time environment. From the sensed information, the model tells within how much time the flood is going to come. If that is the case, this pink color water tube, this will prevents the property from flooding. Okay, so this is also used. I mean, this kind of product also now in the market and used by uh, some countries. And this is about the city of Vancouver. They have signed up with some contract with some company to manage the storm water. Actually, this Vancouver ISDB branch has an archive of data from some 200 flow level monitoring systems. I mean, 200 flow level monitoring locations and some 38 combined sewer overflow monitoring locations and 14 rainfall monitoring locations and 23 water quality sampling locations and 2 groundwater monitoring wells. So for all these, a software is made, and the software will monitor all these locations. Whenever some kind of abnormality is predicted, the software alerts the people, I mean the company, and they will make the necessary arrangement to escape from such kind of things. So this kind of software also available in market now. And this is about the California governor who has banned a bill that would have implemented strict AI regulations, citing concerns about chilling effect on the industry. While some, including the bill's author, they criticized the decision of this California governor Newsom, who advocates for working with experts to develop appropriate guardrails. Meanwhile, OpenAI, the company behind ChatGPT, is raising significant funds and projecting substantial revenue growth. But it is also now facing executive departures and restructuring. And there was another news about Cisco. Cisco has opened its first manufacturing facility in India, aiming to boost its revenue and create jobs while prioritizing sustainability and fair labor practices. And this is outcome of one AI which has predicted if suppose Bangalore city is affected by flood, then how the city will look like. Okay, these are artificial intelligence based images. The information what we can interpret from these images is uh, the concerned people get an idea, okay, if some excess water comes, how these streets and these particular roads may get affected by, is there any proper path to clear the water? So people can take the precautions. So we can make the tool to uh, do our imagination. Okay, if something which is not now, but if it happens in future, then how it is going to be, right? So this images have given a kind of alert to the concerned authorities to look into the paths how to clear the water. And this is interesting research. Actually, now UAE has uh, taken this initiative, that is how to boost rainfall through advanced cloud seeding technology. See, if you want to have rain in your location, then now the technology is available by using this cloud seeding. One can make the rain to happen in a particular location. But this technology is actually now in the initial stage, because there are some ethical clearance should be passed by, because they are using chemicals which causes cloud to happen, and that will result into rain. But those chemicals uh, may also affect our environment. There are possibilities, so people are uh, you know considering that part as well. So now, but anyhow, continuous research may end up with such technology. So we can decide when rain to happen in our place, when to not. Okay. So that kind of advancement is currently happening now. And this is about national, uh, this meteorological department of China, who has created an AI-based seamless precipitation intelligent digital forecast operation and technology system. And some people are, there are so many research articles related to this AI, involving AI in stormwater management system. Uh, you can get many such articles. I just gone through few, and I'm just giving my observation what is actually happening. Uh, in this article, the researcher uh, highlighted several novelties in applying AI to smart cities, which includes enhanced predictive analytics, that is the integration of AI with real-time data sources to predict and mitigate urban challenges such as traffic congestion and power outages before they occur. These things, and Another novelty is adaptive and scalable solutions. AI systems designed to evolve with city needs, demonstrating innovations in self-learning algorithms that can adapt to changing environments and urban demands as well. And another novelty is this holistic urban management framework they have developed in this article uh, by using a comprehensive approach to integrating AI across various sectors like transportation, energy, uh, public safety, and focusing unique methodologies for system interoperability. Right. So when you get a time, you can also look into this article for further information. This is another document, smart management of combined sewer overflows from an ancient technology to artificial intelligence. Uh, in this paper, the novelty lies in integrating AI with real-time data sources from urban water systems to optimize overflow management. This includes innovative predictive algorithms uh, for event forecasting and adaptive control mechanisms that adjust to varying environmental and uh, infrastructural conditions. So these solutions contribute to more efficient, sustainable, and resilient urban water management practices. And I limited this research article into 2, 3 because many you can find such article in the internet. Uh, the last one is about the study which demonstrate AI-driven stormwater management, which integrates IoT, SCADA, and hydraulic modeling for efficient water management. Uh, efficient water management, cost reduction, and flood mitigation. It also emphasizes the low impact development and automated systems uh, whose role in enhancing sustainability and urban resilience. Right. Yeah, as I mentioned, I got an opportunity to work with some of the models in the available time. So I found something interesting. Initially, uh, I was not getting the data set real time. So what I did is I made the uh, code to develop a synthetic data set on its own. And by using that, I have uh, plotted the forecasting. So the model which I have developed follows these steps. Uh, Initially, by using Colab, I have did.
అయ్యో ఇదే
Right. Some interesting conversation is taking place. No problem. Okay. So by importing necessary libraries like Pandas, NumPy, and MATLAB lib.pyplot, we can set a simulation parameters. So how many number of years we want to uh, forecast, and the number of data points per year. So these two parameters I have considered for simulating, and the generate data components like what kind of trend the model should follow. I made the model to follow linear trend and some seasonal pattern, and created an array representing sinusoidal pattern with yearly cycle, and some noise also I have considered random noise values. And finally, I combined all these trend seasonal pattern noise to create the final rainfall data. So without using dataset, I made this, and I made that to work as well. And then finally generated a date range for the simulation period uh, by creating a data frame with date and rainfall columns. Only two columns I considered, and visualized those things by creating a plot of rainfall over a time and set labels for X and Y axis and plotted the display results. So the result what I have got for some 10 years, I made the code to generate data on its own for 10 years, and I have instructed the code to consider values for each year, and I applied all the uh, patterns, and I made this kind of time series rainfall simulation for 10 years. Then I took some data set from my friends. When I checked with others, they said we need to approach IMD to get the data set. And there are some data set in the uh, Kaggle and in fact in NASA website. In fact, I got access to Hyderabad location data, and I have played with those data as well. And the another thing what I did with data set, I made the model to prepare and load with the libraries, uh, initial libraries like pandas and matplotlib, pyplot, and cbond statistical models, and loaded rainfall data from the CSV file. And I have set year column as the index and handling missing values like interpolating. And for visualization, plotted the time series of annual rainfall and created a histogram to visualize how the rainfall distribution is over the year. And some stationary check also I have included by using add fuller function, and some autocorrelation and partial autocorrelation a study also done on the data set, and some seasonal decomposition I have made. Model fitting and residual analysis I supposed to make, but I have considered this ARIMA model for generating the results. So it's like with fun, I just played with data and changing the different parameters, and I have gained the confidence now. Whatever be the data I get, I can make the data to generate. I make the data to work, and we can get some useful results like this. I have generated a monthly rainfall trend from the data set, which has some rainfall uh, details in millimeter ranging from 60 millimeter to 140. And I considered the, the year duration from 2010 to 2020. And this shows that the rainfall information. So there is no big variation in this graph. Actually, the variation is between some 110 to 70. Mostly, it is actually in the mid range of rainfall between 80 and 120. Yeah, of course, we can observe this information from the data set itself, but when the data set is having more number of records, it is difficult for us to visualize and understand what is the what is the average range of rainfall we got so far, right? And also I generated this rainfall distribution by month, how in a particular year, how the rainfall was each month, month 1, 2, 3, up to 12, uh, plotted the rainfall in terms of millimeter. And also I made forecasting as well. You can see the same 2010 to 2020 data I have considered. That data was used to train the model. So model generated the rainfall graph distribution over the years. And I considered some parameters based on that. I have predicted how the rainfall could be in future, but this may not be correct, or this may be correct. How we can make sure that the model what we have developed is correct. One idea, if suppose we are having 10 years of data, we can make the model to generate a distribution curve for 8 years, so that we left with 2-year data with us, and we can make the model to predict for those 2 years. If that prediction matches with the data what we have, if it matches, then we can tell the model is good or it is accurate, or how much percentage of accuracy it is, or where it is deviating. So we can also uh, continue research in that aspect as well. Okay, so for any kind of data, it's need not to be rainfall. Whatever may be the data we have, we can forecast with the help of available time series prediction models and ARIMA models, right? And this I tried with another data set where I took some, in fact, this is about the Hyderabad location. I have collected this data from NASA LARA website. By using this, we can, I made the model to generate the distribution, how the rainfall over from 1981 to 2023. So this is the rainfall in terms of millimeter range in Hyderabad city over the years. As per NASA data set. Okay. And these are different patterns, the seasonal pattern generated from the data set for 1981 to 2023, which tells about how the seasonal rainfall was during the seasonal, how it was, and you know, and other parameter like trend and resid, those information also I have generated from the data set. And I tried some prediction using the model which I developed, but I got some result, but that is not correct, because this data set needs to be cleaned, because there are so many, uh, you know, zero values. Because while downloading the data set, if we choose, we are having option to choose whether month-wise data we need, or year-wise data need, or date-wise data, or time-wise, hour-wise data. We cannot expect, if suppose we are choosing day-wise data, we cannot expect rainfall in all the days. So obviously, many records will have zero values. So we have to be careful while choosing the data. All data, I mean, all records should have proper values. Otherwise, we have to make, or we have to follow some approach to match the zero values or missing values to the desired range, so that the model or the prediction maybe uh, in a better way. Okay, so the same graph uh, which was generated by the model from 1981 to 2024 up to this, and I just for fun I made the model to predict, so that predicted these two lines, but these two lines may not be correct, but these two lines are actually falling within the range of lower range and mid range, so there may be the chance this forecast may be correct or incorrect. As I said earlier, if we have some 10 years of data, we can keep some 2 years data as backup. We can give only 8 years data to the model and generate the graph. And we can make the model to predict for the remaining 2 years, and we can compare uh, the, the generated results with the 2 year data what we have. From that, we can decide whether the model is working as expected, or it needs to be fine tuned further. Okay. Yeah, the same data set with I have chosen day wise information, and I just want to see what kind of pattern it is going to generate. So I just made a time series model to work on the data set. It has plotted like this. Because it has some huge number of records. So while plotting all the values, we are getting like this. If we uh, make the data set as small, or having some gap between the data points, so we can get some useful uh, graph. From that, we can extract some information as well. Okay. Right. So without cleaning the data set, without pre-processing the data set, if we work, then we may get like this kind of distribution graph. And this is about the histogram which I have generated from the model. You know, you are all familiar with the histogram shown in this figure is actually right skewed or positively skewed. This means that the majority of annual rainfall values are concentrated on the lower end of the distribution, uh, with a tail extending towards higher rainfall. Okay. Because the annual rainfall is increasing from 0 to 6,000, so the tail is extending towards a higher rainfall. And what other information we can get from uh, this histogram is we can look at the mode. The mode is like it is coming around some 800 range, 800 millimeter rainfall. So this is the most frequent annual value of rainfall. Okay, if once we get the mode value from the histogram, that is the most frequent annual rainfall information. I mean value. And we can also look at the median from this graph. The median appears to be somewhere between 800 and 1000, okay, the peak. And so this means that half of the years had uh, rainfall below this value, and half had rainfall above it. Okay, so that is the information we can interpret from this histogram. And we can also calculate the mean value from this histogram. It is likely to be higher than the median due to the right skewedness, because sometimes we may also get left skewedness histogram. Since it is a right skewedness, the mean value is higher than the median, and it would be influenced by higher rainfall values in the tail of distribution. Okay, since we are getting some higher values in the tail of histogram, so that would be the reason why this mean is getting like this. So like this, we can interpret information from the graphs generated. And this is about the autocorrelation function, which I generated using the data set. Generally, we know correlation means it's relating two variables and then generating the relationship between the two. So this is about the autocorrelation and so here in this plot, actually, the annual rainfall data from around, you know, 1900 to 2020. So that was the data considered. And that data appears to be quite volatile with significant fluctuations in rainfall from year to year. This autocorrelation values are plotted between -1 to +1, the range. So, and also observed the partial autocorrelation for the data set. The partial autocorrelation plot, it shows there is a rapid decay. Initially, it is starting with higher values and then it is quickly reaching to the zero range. In the partial autocorrelation coefficient, as the lag increases, when the lag value increases, it is falling from higher to zero range. So this suggests that this time series data has significant partial autocorrelation at shorter lags. Okay, at shorter lags, it has significant partial autocorrelation. But this correlation diminishes quickly as the lag increases. You can observe in the x-axis, as the lag value increases, the autocorrelation is, partial autocorrelation is getting diminished. So what we can observe from this figure, there are some significant lags and the values are rapidly getting decayed, and yeah, these things we can get from this. Right. So similar to the previous work, I generated some different patterns from 19 yeah, this is showing from 1900 to 2020. Okay. Yeah, and so you can also make models with the help of, if you know the Python Colab, you can make the model by giving the data set to the model. You can train and make the model to predict. After prediction, we can think of how to fine tune the model, what parameter we have to fine tune, and we can validate as well. Okay, right. So it is possible. I made this work in just 2-3 days of time, which I got because we computer people have knowledge in coding, how to make the code to analyze the given data set. So by making coding, we can make the model easily. And finally, there are some companies who are actively engaging themselves in creating stormwater management systems. So when you have the time, you can look into it. Let me show you some of the websites who are actively involving in the stormwater management system. Autodesk ATAL.com is one of the company who are utilizing satellite-based sensors. So they have sensors at satellite. So from the satellite, they sense the environment. From the sensed information, they are making their model to work, and that is giving predictions, right? Uh, you just look into this website, you get more information how this autodesk.com is contributing towards stormwater management system. And the planet.com is another website who are also actively working in the stormwater management. In fact, all renewable energy related information they are collecting, and they are working with that. So since these models, AI models are working based on satellite imaging, so they're getting data time to time, and they have made the model to work, because time to time means all parameters, how many features they are sensing, that many features will uh, generate data time to time, and their model supposed to work continuously, because they they would have made the model to get trained to work and work continuously on the incoming input, so that the predictions are happening, right? And this is another company, maxar.com. So they are also uh, providing uh, this storm water management system assistance with the help of artificial intelligence tools. Uh, this company is actually offering range of satellite imagery and geospatial intelligence solutions, including high resolution imagery and advanced analytical capabilities as well. ICI is another company uh, who specializes in synthetic aperture radar. You might have heard about SAR images, satellite based on satellite technology. They are providing data for applications like maritime surveillance, disaster response, and infrastructure monitoring. So all kind of solutions they are offering. ICI. So these are some leading artificial intelligence based companies in stormwater management systems from private sector. There are some government agencies, they're also playing good role in this domain. One is well known, NASA. When you get a time, please visit to this NASA. You get a lot of information. Mostly the information what is available, some information we can get it free, some are for confidential information. The confidential information we may get it by request, but other data set kind of thing we can get. Even you can get for your location, own location, you can get the data from NASA as well. Okay. It utilizes satellite data from various missions to study uh, Earth's climate, atmosphere, and surface. Um, this is one of the leading government agencies in the world, and another government agencies from European country is European Space Agency. This agency conducts wide range of Earth observation mission, and they provides access to satellite data for research and commercial applications. So if you want to use uh, these government agencies data, then you can also visit these websites, and download the data for research. Of course, for academic and research, uh, we can utilize their data without their permission as well. Okay. But if we are commercializing, we are making a model, from that we are generating revenue kind of thing, then we supposed to get prior permission from the owner. Otherwise, we may be in trouble. Okay. And apart from this, there are some leading research institutions across the globe. They're also working and contributing in the stormwater management system. Uh, so I hope I have shared some information which would have created spark uh, for you to work in this field and choose problems and come up with some ideas. I believe some people would have got some research problems from the discussion. Even if you are finding difficult to locate your, decide your research problems, or you want to make your model to work, or you want to visualize your data set, what you have, you can always approach me for such kind of solutions. I'm always open for collaborative work, and you can get my contact details from this. And let me take up some questions quickly if you have uh, any things to be get clarified. So let me stop sharing and yes. No question is silly. All questions are answerable. If not by this time, surely you will get answer in short short span of time. If you are hesitating to ask question, you can mail me or WhatsApp me whenever I find time. Surely I will help you to get the correct answer.
Sir, can I know from where we can get rainfall data?
Yes, madam. You can get it from NASA website if you want to get global data, global location data. Uh,
Or if
I
it is
mean,
for India only, then
yeah, I took Hyderabad data from NASA website, which is having record from 1981 to 2023. Yeah. And some Kaggle also having, even this European Space Agency, they're also having data set. So whenever we refer some standard data set, the data set which are universally accepted by other researchers, if we use that data set in our work, uh, the chances of getting acceptance is more, because many people would have got access to that data set. So whatever we are claiming, they can also, uh, you know, work and validate with the available information. So if we go with our own data or some unknown data, then reviewer may find difficult whether these people are really giving actual information or cooked up information. So that kind of uh, you know feel they may get. So better using standard data set is always advisable. If you want to have uh, you know particular location, like in India, in particular state, particular location, even you can approach from IMD, Indian Meteorological Department. If you are a research scholar, after getting bona fide from your institution, if you approach IMD, you may get the data. Sometimes they may charge, sometimes they may give it for free. If you have any known working people at IMD department, you can easily get all rainfall information, actual rainfall information.
Okay, sir. And one more thing, sir. Which are the parameters we must evaluate for rainfall detection? No? Only we train the model and we have checked the accuracy
Yeah,
of the model, or any other parameters we have to evaluate, sir?
yeah. Because I didn't disclose that information during this discussion because I took only 2 columns of data for the code simplicity because I hardly got time to run my code. Only I spent 2 days to make the model to work. So I don't want to mess up with things. So I took only 2 columns. One is the year and the other column is rainfall. So with that, I plotted these. If we are taking, if our data set is having more number of features, then based on the features, we can make a case study. I mean, which parameter is influencing. If suppose you are creating a model and that model is giving better result, then you can stretch out due to which parameter. If you are considering some 10 parameters to model the machine, then you can have a study which parameter out of this 10, which parameter is contributing more and which is contributing less. If you know that, you can drop the parameter and you can reduce your complexity, or if you find the contributing parameter more highly contributing parameter, then you can use that with more clear kind of information. So whatever parameters we are considering, from that we can stretch out further. If you have a data set with you and how many number of parameters you have, then you just share with me. I will tell you what kind of direction you can take the problem into.
So please share your mail ID, sir. Then I'll share it. No.
Yeah, my mail ID I am sharing. You can also get it from Dr. Murugan.
Yes, sir. I will share your mail ID with participants.
Okay. Thank you, Professor. Yeah, you can take my contact. So if you have questions, you can WhatsApp me or mail me whenever I get time. Surely I will respond. And I take this opportunity to thank all of you joining today and witnessing and gaining some knowledge. If you take this information And if you process this information to a next level and come up with some fruitful outcome means I would be happy. Okay, if no more questions, I think we can stop here because another person also about to start the session, it seems. Okay. I hope I made a spark on this particular topic because uh, artificial intelligence, stormwater, both are, you know, big ocean. We cannot learn it in an hour. So it requires a lot of time. So whenever we find time, we can meet again and discuss further. So if no more question, thank you all. Thank you, Dr. Murugan and the Institute of Madanapalli Institute of Technology and Science for giving me this opportunity to share my views and knowledge in stormwater management system. Thank you.
Thank you, sir. Thank you for your valuable input, sir. Thank you.
So shall I sign off, sir?
Yes, sir. Thank you. Thank you, sir. Thank you.
Okay. Okay. Thank you. Thank you all. Bye.
Participants, our next resource person will be joining shortly. Please be online. Good evening, everyone. It is an honor to introduce our distinguished resource person, Dr. D. Yuvraj, a highly accomplished professor and a research director with a career spanning over 23 years in the teaching domain and 12 plus years in research. Currently serving as the head of research at Jihan University, Kurdistan region, Iraq, he has played pivotal role in coordinating departmental research operations, fostering international collaborations, and organizing international conferences and workshops. His academic journey is marked by a doctorate in computer science and engineering from Anna University, Chennai, and postgraduate and undergraduate degrees in the same field from esteemed institutions in Tamil Nadu. His prolific research contributions include over 100 plus articles in SCI, Scopus Indus journals, book chapters, and a textbook published by renowned publishers such as Willie SNB, etc. With 20 plus 1 patents, 3 granted, he has left a significant mark in innovation and intellectual property. He has excelled as a mentor, guiding research scholars and project teams while also delivering lectures and conducting evaluations with unmatched dedication. His research interests encompass image processing, Internet of Things, computer vision, machine learning, artificial intelligence, and data science. As a testament to his excellence, he has been awarded the Best Faculty Award for Research Publication Performance, along with an award for excellence in research and teaching. We are privileged to have such a versatile and accomplished professor with us today to share his profound knowledge and expertise. Please join me in welcoming Dr. D. Yuvraj. Welcome you, sir.
Thank you so much. Can you hear me?
Yes, sir. You are audible, sir.
Yes. Shall I start? Shall I start our session? My session?
Yes, sir. We can start, sir. Thank you.
Okay. Thank you so much for giving opportunity. ATAL sponsored FTP program from Madanapalli Institute of Technology and Science. I would like to express sincere thanks to the department, the management, the faculty members who are all organized the online FTP program, 1 week FTP program under the cybersecurity department. Okay, now I'm going to present about artificial intelligence for flood prediction and management system. It's normally we know the flood is now in India. It's a rainy season. It's the rain having a lot of creating a lot of issues in and around in Tamil Nadu and Kerala, Karnataka during the rainy season. In this moment, how we are going to predict the rain, overall rainfall and the the maximum rainfall, and how we are going to manage with the AI artificial intelligence system. First of all, I would like to share some basic information about traditional information and how what are the important methods are available, what are the challenges and the basic needs, and what are the why we need for artificial intelligence methods, and here and what are the techniques and methods we are going to use in the gender flood prediction management system. Here, my name is Dr. Yuvraj Duresami. I'm a professor at Department of Computer Science, Jigan University, Dubai. I have been here for the last 6 years, professor and research director from the university. Yes, today we are going to discuss about the flood prediction management system. Just we are going to start with the architecture, and we are going to discuss about the traditional methods and flood prediction, and traditional flood management methods, and the strength of traditional methods, limitation of traditional methods, and what's the need of AI-based method, and what are the key techniques we are going to use implement the current system. AI flood prediction management workflow. What are the basic technology and tools we are going to use, the techniques, and detail some example detailed insights and then some of the applications area where we are going to use. First of all, I would like to start what is flood prediction management system. Formally, how we are going to predict the flood. It's during the rainy season. How we are going to identify the flood. Too much of rain. Too much of rain. It's happened means flood will be happen. Here formally, how we are going to predict the flood and how we are going to manage it. This is the basic aspects of inside the process. Here in this process, how we are going to utilize the artificial intelligence. To use of artificial intelligence technology, here what we are going to use means we can use machine learning and data analytics and sensor and monitor and to identify and manage the floods. Here, the particular system, we can analyze the water data and the river levels and the historical flood patterns. How we are frequently the last 10 years or 15 years, 20 years or 100 years like this, you can use the historical data. We can collect the historical data and provide the based on the historical data it's maybe happen like this with this scenario means it maybe happen like this we can give some prediction and give some warnings and assess the risk if it is happen how we can going to manage and avoid the problem and how we are going to take some support decision making process. It helps to reduce the impact of flood, predicting, protecting lives, and minimizing the economic. It's a very important thing. For example, currently it's happened in Tamil Nadu last 2 3 days before. On general, the particular cyclone it's happened, but they're expecting one place, but it's redirect to another place. Unexpected place, a lot of rain, the flood happened. 2, 3, 4 districts are totally damaged. Lot of lives are uh, saved, but a little bit damaged, and the lot of economic things we can loss of many things. Their people, their own agricultural land or something, individual houses and their day-to-day activities, they lost them their lives also. Like this here in this scenario, how we are going to predict the entire flood happen, flood prediction and management, how we are going to manage and how we are going to predict and manage the entire process using the artificial intelligence. Here, formally, the flood for forecasting management process, we can have three, four different phases is there. Mitigation and preparation and response and recovery. Formally, each and every phase, it's very important role. Mitigation and preparation. Just you can go for the some warning. What are the things it's going to be identified? It's happen. We can identify, and you can go for further preparation for this, and after that happen how we are going to respond how we are going to respond the any scenario, and after that how we are going to recover from the process. These are the four important phases of it's any surgery or a flood or something, so any happen, we can go for the four important predictive assessment and descriptive assessment. We can categorize two important things. And predictive, we can mitigation preparation and the descriptive assessment. We can have a response and recovery. We don't know how it will happen, how we are going to collect the information and based on the things and how we are going to respond and how we are going to recover the existing what will happen, how we are going to do the further process. Like here we have a system architecture. It's described about what are the if I'm going to implement AI system means what are the things it's going to be included. Here first weather observation is there, and we have weather forecast and weather forcing, and watershed condition. These are the three important things are interconnected: weather observation and weather forecast and weather forcing. These are the three important things are interconnected, and also watershed also the other phases. Here we are going to shape in all the phases like round of generation and routing, and they're connected in the flood inundation and risk. These are the some basic process are included. Here weather sheet properties, how it will the water flow it's happen, how we are going to identify how much of amount in water in flow in the particular area. We can make some calculation like this. And we have covered workshop, we have hydrology and machine learning process. We can make the two different color is mentioned, weather forecast and weather condition. It's all by the machine learning process. And the blue cover like a weather observation, weather forcing, and the watershed properties we can by the hydrology process physically. And we are going to use the system also. We can both combined system how we are going to process. And here second phase we are going formally what are the observation with the existing data, how we are going to manage the in forthcoming calendar year or something forthcoming season. Here we have weathershed type and dominant process and modeling strategy, what we are going to use. This is the traditional way. And optimization validation is done by the machine learning process. And uncertainty assessment and operation issues. These are the things it's happened by hydrology. That means formally here we can go for the traditional methods. The combine the artificial intelligence, how we are going to integrate with the existing model, artificial intelligence, the existing model, how we are going to create the new uh, proposal structure for avoiding the flood, the flood in the rainy season. Here, for that purpose, just I'm going to discuss about the traditional, what are the basic traditional method is there, how we are going to process the traditional methods and flood prediction process. Here we have flood prediction methods. Here rainfall and rainfall round off model. This is the basic traditional method. Here we are going to calculate round off based rainfall intensity and
The
catchment
slide
area.
is not moving, sir.
It's now, it's okay.
No, sir. No, sir. It is not moving actually.
It's with only one slide from the
No, sir.
which slide is there?
Still you are in the first slide. AA for flood prediction and management. 412.
Yeah, sir.
Yes.
Yeah.
Yes. Then why? Just okay. I will check it. It's okay. Can you see my slide screen? Hello, Mr. Murugan.
No, sir. No, sir. Now you are in the second slide, I think. AA for flood prediction and management. Yuvraj Duraisamy. That
Yeah,
slide
my
is
name
visible.
is there. Yeah, it's not
Yeah.
now. It's moving.
Now third slide. It is not moving, sir. Actually, that same slide is there as of now.
Moving, sir. Let me check.
It's third one. It's okay. Content.
Now it is moving, sir. Now content is
Yeah.
visible.
Okay, okay. If I make it a slideshow, it's not able to move. Okay, no problem. I can make it like this. Okay, it's okay for the screen is clear. Hello.
Better than book a slideshow.
Yes. Now I'm in fourth slide. Can you hear
Yes, sir. It
me?
is moving. Yes, sir. It is moving, but the size of that slide it is very small. That's why they are asking most of them.
Okay. If I make it here, it's okay.
No, so same position only it is there. It is not
Now,
maximized as of now.
no, now maybe it's a time delay. Maybe I just we can check it now.
No, sir. Still it is in minimum size only. It is not maximized as of now.
Slideshow.
Yeah, I'm in the slideshow mode only, but maybe in the internet status. Yeah. Yeah, it's okay now. Hello. Hello. Sir, anyone coordinator, please guide me. Hello.
No, so still it is in same small size only. But if it is not possible, means you can continue. So no issues. I think. Actually, I am the
Okay.
participant. I am not from organizing side. Yeah.
Okay. I will share the PPT after the presentation. Okay. Just we can share the same to all the uh, participants.
Sir,
Okay.
now are you in slideshow, sir, or in normal mode, sir?
This is now in normal mode. Now I am in the
If
slide.
you F5, F5 you press, sir.
Yes.
F5.
Yes. Yes. I pressed the
Maybe
F5.
the
Yes.
button. Now
I
it's
am in the
on full screen.
slideshow.
Sir.
Now in slideshow mode. It's okay.
Maybe yes, maybe some Teams problem is there, sir. So okay. So you can continue. Later we can share the slides, sir.
Okay. Okay. Okay.
And
Yes. Now it's moving.
yeah, moving, sir.
Okay. Okay. Yes, just I'm going to discuss about the traditional methods. What are the basic
Or
traditional
else you
methods
can
today?
move, or else you can zoom the level, sir. Zoom in and can you please zoom out, zoom in, sir?
Okay, it's okay.
Yeah, yes, sir. Okay. Little bit, sir. Little more.
Yeah,
Yeah, yeah, but you have
it's
to
okay.
the content is
Yeah,
going beyond the one. Okay, sir. Yeah, okay, sir.
yeah. What's the
Now it's
problem?
okay, sir. Fine, sir.
Yeah, yeah. I already shared in the mode also. I don't know what's the problem with the internet or something in the team. I don't know. Okay, no problem. Yes, flood prediction. Just I'm going to share some information about the traditional methods. We have rainfall round-off model. The calculate the runoff based rainfall intensity and catchment area characteristics. Formally, here we are going to calculate just each and every area. We can identify what are the historical data it's happened in the last year or the previous year. Then here, what are the basic level of the catchment area? Thus, we can calculate based on the things. Then we can go for the further process like this. Here, use empirical and semi-empirical equation like rational methods or SCS curve numbers. In this method, we have some limitation is there in inaccurate and high uh, unurbanized area. We can't able to calculate the exact information, and we have for complex environmental impacts also is there. We cannot account of the basic information like statistical methods. The second one, we are analyzing the historical rainfall. It's normally it's based on the data. Nowadays the rain forecast or any cyclone forecast like this based on the existing data. Then they will compare with the current data like this historical rainfall and river flow. How much the the river can occupy and how long it will go through the things, and flood data predicts the future events like this. This is the statistical model. Here in this method, a long term and reliable historical data. It's formally we have to collect all the information. It's like every 5 years or 10 years or 20 years like this. We have to collect all the information and the reliable information. For the it is a less effective. Formally, it's the traditional methods compared to now less effective for the rare flood events. Formally, just we can avoid little bit only. Here we have hydrodynamic model. Here stimulate water flow in the river and the flood plains. Formally, here physically we are going to make some water flow in the river and flood plain. Just we can evaluate the physical equation like this. For example, if you are going to check how much of amount water just it can be occupied or it can flow through the level, just we can check in the minimum uh, simulation level. Then based on the things, we can go for the further process, like computationally it's intensive. That depends on the heavily on the accuracy input data. Here, formally, here it's a basic, the traditional method, they're having lot of limitation is there. Is the hydrodynamic model. And meteorological forecasting methods here use weather pattern and atmospheric data, predict the rainfall and storm condition. Formally, basic tools we are using a numerical weather prediction model. Here in this method also we have a short-term and localized forecast. Formally, based on the current information only, we can predict and assess the information about the rain forecast or anything, the weather forecast also. Here, the insufficient in predicting the flood flows and urban flooding. Formally, the data can be give some specific information. We can't able to identify the 100% of the flood forecasting through this execution like this, the meteorological forecasting method. And we have formally how we are going to identify the real time and forecast method. Formally, the data driven flood mapping is defined, as well as the forecast participation forecast, machine learning and water level forecast, data driven forecasting is combined in the particular picture. Here we have some existing system is there. Just I'm going to flow some water in this area, means how it will what will happen, how we are going to manage. It's a we can we can assess some basic information with this real-time water level and participation forecast status in the same process. Like this, from the traditional method, we can observe what are the limitations and what are the problem is there. We have to list out all the problems and the limitations and the and then the how we are going to avoid this problem. Then we can go for the new method. Here we have another this forecast, how we are going to manage it. This is here we have uh, forecast manage traditional flood system. Here the management after flood happen, how we are going to manage in the traditional methods like this. We have first one, flood control infrastructure. Formally, we have to make some dams and levees and reservation regulatory water flow, reduce the flood risk. Formally, here we have to create some physical uh, assets like avoid the flood damage. Here we have to create some dams and lake and the reservoir regulators like this. Here we have in this methods is expensive one. For example, it's we have to create and each and every area it's a dam or a lake, means it's very difficult. The manpower also economic also it's not it's supported. Like this, here the flood control infrastructure it should be it's the one type of method to avoid the traditional method. And here we have a drainage system also is there. The proper drainage system in this any urban area or city or rural level, we should make some a proper drainage system, means we can avoid some flood flow process. Thank you. Here we have floodplain zoning. Just we can identify the restrict and development and the flood prone areas through the regulation. Formally, we have to identify what other things is there, and we have to design some restrict development for the particular area, and the rules and regulation of the each and every square meter area. We have to give some specific information and some rules and regulation for creating the floodplain zoning. Here we have enforcement challenges there, may not account of informal settlement. And flood forecasting and yearly warning system. Formally, nowadays we can all the state and central government they are given some information about the weather forecast or flood forecast or something rain forecast like this. It's based on basic information. We can give some alert to the people. They will aware about the rain will be happen or cyclone will be happen like this. But we can't able to give 100% surety for the forecast. Like for example, I can say here, for example, I'm in Iraq in Kurdistan region. If in the weather forecast, if they make today it's rainy, means it's rain happen. 100% rain happen here. I don't know in India. I haven't checked, but sometimes the news they will telecast like this. Tomorrow it may be rain, but we haven't get any rain. But here, almost I can say every day or the here now we are in winter season, but the majority if it is sunny or rainfall or shower means it's automatically they mention means it's almost 99% it's happening. It's 1%. But in India, I don't know what's our weather system or the weather forecast here. And just I'm following here only the Google, the inbuilt app only. I don't know in India. Just we can check only the our temperature only. We can't able to predict the entire process. We have to change to uh, identify the new system for identifying the forecast process like this. Here we have the traditional methods how we are going to manage means here flood forecasting early warning system is there and manual evacuation plan and post flood recovery. Formally, it's happened. How we are going to manage? Uh, what is nowadays we have a separate some system like a police and military like this. We have some specific system is there. Each and every state they are having quarters. If anything happens, they will go and the particular people they will go uh, and help the people and to get recovery for all the people and the things like this. Here relate to three different routes communicate the coordination and the post flood and forecast rebuilding the infrastructure. How we are going to give the things to the people like this. These are the some basic traditional management system. It's available in the after after flood. Here in this overall system, what are the advantages? That means here we have the some specific information about the here we have a strength, the basic strength of the means simplicity and proven techniques and scalable. Formally, the traditional method is easy one. You can easily execute and access the method, and it's already proven techniques. Lot of time we already executed and collect the information and share the things, and scalable can be adapted to local condition without high tech resources. Formally, it's a traditional method. We can manage with the available people or available resources. We can easily execute. This is the basic strength. And the limitation of the traditional methods here, lack of real-time data can give some formal information only. That means the existing historical data. Based on the existing historical data, we can give some information. Lack of real-time data depends upon the statistical data or manual update and limited accuracy. For example, I already told about the accuracy level is very less. We struggle to predict the short-term and localized extreme weather events and high dependency on infrastructure. Yeah, here required significant investment of physical infrastructure. Formally, the traditional recovery system, or we are going to be means we have to make some lot of investment and inflexibility, hard to adopt dynamic environmental change to urbanize it. Formally, we cannot able to utilize the same system for entire areas or entire district or something. You can we have to predict and uh, we have to utilize the specific information and resource intensive. Yeah, formally, how we are going to use the based on the resource. It's also very lack of the experience. We can't able to do that. These are the some limitation of the traditional methods. Here we have what's the need? Why we are going to compare with the traditional methods with the AI based method? Formally, if I'm going to use both two different methods, the four different aspects: accuracy, adaptability, and cost, and real-time insights. These are the four important aspects I'm going to compare with the traditional method as well as the AI-based. Here, accuracy level is moderate compared to AI-based method. Here is high accuracy. Here we can learn from the real-time historical and driven data sources. Formally, we can capture all the information, what are the sensor or existing system is there. From the system, we can collect all the information, and the accuracy of the level is very high. And adaptability also here limited preferable model. It's formula traditional methods we can use the specific area or specific resources, but here highly adaptable with the dynamic learning capability. We can use for any type of condition, any situation, or any uh, any place like this adaptability. Cost here traditional method is its process is very high upfront cost. Here the cost effective, how much you are going to invest, and then we can get that much of returns from the AI based method like this. And real time insight, yes, it's limited in the traditional methods. The AI based methods provide real time monitoring and the prediction process. These are the some comparison between traditional methods as well as the AI based rain forecast and management system. Here we have formally why we need for AI based flood management system. Why we need for flood management system, flood prediction and management system. It's formally based on the traditional system. Here we have to we have to move on the new technology with accuracy one. Formally here it's a more if any flood happen means here it's like a natural disaster causing loss of life and the property damage and the long term psycho economic impact. It happened. It's all happened. Yeah, formally, if anything happened, uh, like flood or rain or something, any weather uh, forecast, it's not fit with our current scenario. Means it's always give the very big damage. Here we can call it as a natural disaster. Yeah, like this. The traditional method of flood prediction management often we can use little bit the fall short on handling the complexity. For example, the existing method we can use. It's like a 20 to 25% we can manage. Yeah, we can't able to get 100% accuracy or 100% protection for the people. That's why we need some new system, AI-based method for the rain prediction, flood prediction, and the management system. Here, AI methods have emerging essential tools. Formally, here artificial intelligence, we have a different technology and tools is there. With the tools, we can create and we can give some specific suggestions or accurate information to the people and to avoid the natural disaster. Yeah. Here we have what are the importance for the AI needs further increasingly critical uh, uh, periodical flooding events. Yeah, formally you can see due to the climate change, entire world they're affecting due to the flood. It's maybe Europe country or like Africa, like this different country and Pakistan also there having climate change, lot of flood it's happened. And India also sometimes every year in Tamil Nadu, every year the one cyclone is happen and due to the cyclone, each and every at least 3 to 4 districts are damaged during the each and every year, heavily damaged. I don't know what's the problem like this due to the climate change or something. It's not happened last 5 years or 10 years before. Recently, last 10 years, every year we have a cyclone and a flood happen. It's every particular area like this. Yeah, climate change, urbanization, and environmental degradation. These are the important due to the things our climate entirely changed like this. Here, what's the need? Why these methods are necessary and how they contribute? Here, if I'm going to develop AI-based methods, means what are the important things and how we are going to what are the things are going to important matter I can observe from this one means. Here, if I'm going to develop the AI-based method, the enhanced accuracy in prediction. Formally, the prediction should be 100%. Yeah, accuracy level should be 100%. That means our system give some means at least 90 to 95% accuracy. And real-time monitoring and alerts is very important. Formally, our system, if I'm going to develop any new technology means if any flood happen, suddenly it should be indicate to all the people. To our, they should aware about what's going to be happen like real time what are the things it's currently it's going on and like this what will be happen like this we have to give some alert adaptive management strategies and what are the different type of strategy we are going to execute and how we are going to follow the things and we have to design some basic strategy for the new design and addressing urban flood challenges what before the traditional methods, what the drawbacks of traditional method, how we are going to avoid this one, these are the things going to be addressing urban flood challenges and climate change adoptions. Here, due to the entire world, the causing by the climate change, what will happen like this, and we are going to give some cost-effective solution. Our system should be the performance should be high and cost also it should be less like this. We have to design and develop the new system with the AI-based method. Here we have formally, I'm going to what are the basic key techniques in the flood prediction? If I'm going to utilize the artificial intelligence techniques in the prediction system means what are the key techniques I'm going to use means here first of all I'm going to use machine learning process machine learning here we have regression model and random forecast and gradient boosting predicting the rainfall and river levels. Here, just we have to how we are going to analyze the existing data and what are the existing uh, area is there, river area is there, how we are going to process this all by the machine learning process. And we have a deep learning methodology also I'm going to use. We are going to use for predicting the system and conventional neural CNN method as well as RNN method, conventional neural network and recurrent neural network. Here, with this process, we are going to satellite image and time series data is based on existing data. I'm going to compare with the existing data, the current satellite imaginary and the real-time series. Just need to compare if anything changes and how we are going to predict and suggest some information to the concerned people like this machine learning and deep learning process. And here we have another two important technique is there geospatial analysis as well as natural language processing. GIS, integration of geographic information system. Geographic information system with AI, flood mapping and spatial risk assessment. How we are going to identify the flood and uh, how we are going to map artificial intelligence, the flood process and the spatial risk assessment. What are the spatial the risk going to be happen? How we are going to assess the risk? It's all by the geographic information system GIS. Using the GIS, we can identify. And also here we are going to use the natural language processing system NLP for analyzing the social media and news fed to the monitor. What are the basic news are in around news channels and their social media, flood-related public sentiment and real-time information. These are the information that are collected and gathered, and we can use for the further process like this. We are going to use natural language processing. There are four important AI techniques we are going to utilize flood prediction: machine learning, deep learning, geospatial analysis, as well as natural language processing. Here we have basic management workflow is there. You can see some our technique Can you see the diagram? Anyone? Hello? Can you hear me? Is my
Yes, sir.
voice
Yes,
is
sir.
audible? Yes, sir.
Yes, sir. Yes, sir.
Okay. Yeah, this is the workflow, flood prediction workflow using machine learning techniques. Just you can have a different phases is there. Different phases are how we are going to like system development like this. First, I am going to collect data collection and exploratory data analysis and future engineering and model training and model evaluation and model deployment and model improvement. These are the different phases of flood prediction workflow. Here, each and every phase they are having own steps and processes there. In the data collection phase, we are going to collect geographic features and hydraulic features and land cover features. Just we are going to collect all the information, whatever we want and predict the system. Just I'm going to collect all the data. And exploratory data analysis means based on the data, how we are going to analyze the data, descriptive statistics and features distribution and culture. So based on the existing data, how we are going to extract the information from the exploratory data, from the data, just the data analysis. And the future engineering, here we have the further steps. Just we are going to normalize and standardize and data transformation existing data, how we are going to normalize and filter the data and compare with the existing one, what are the needed information or the unwanted wanted information, unwanted information, just we can separate and go for the further process. Here, the next one, model training, just based on the existing data, just I'm going to train the data, test the data, and the hyper parameters. And we have the next phase, we have a model evaluation. Here we have existing test data. Here, it's how it will work, the error metrics, and I can identify example F1 scores and JSS. Just we are going to fix the process and the before the final process, model deployment. Here, flood prediction and warning. Just here, I'm going to give some specific messages or alert to the concerned person, model flood prediction and warning to the people from the system. Here, the model improvement, updating the input and the new scenario. Formally, it's currently what will happen, and if the new data it comes, how we are going to correlate with the current data with the existing data, and here the model improvement. The entire system can be divided into three different phases: and transformer, and estimator, and evaluator. These are the three important phases. 1, 2, 3. There's a data collection, explanatory, and the future engineering. We can transformer, just collecting and analyze and extract the information. Just we can transformer and estimator based on the data, how we are going to test and process and execute an estimator, and the remaining the evaluator. The final phase we have a model deployment and model improvement. The evaluator, the finally how we are going to evaluate the particular system. So this is the way we are going to design our system to predict the flood prediction process. Here we have uh, technology. The basic technology we already key technology we already discussed here, and what are the basic tools? Technology and tools are what are the tools are going to use in the particular system? Here, the machine learning algorithm we already discussed. It predict the rainfall, river discharge, and flood events. We can use in machine learning algorithm. And the remote sensing, using the remote sensing, satellite images are combined with AI detect the changing land and the water system. Formally, from the satellite image and with the sensor, how we are going to capture the current situation, current status of the area, land, and the water system. We can capture the information. And IoT devices collect the real-time hydraulical data and AI for AI. Formally, we can fix and each and every important process, some sensors and some specific systems going to inbuilt with the AI system correlate the real-time hydraulical data for the to analyze the process. Here we have cloud computing. enable the real-time processing of large data set. For example, if I'm going to collect the some information from the remote sensing as well as the IoT devices, means how we are going to process entire data and transfer the cloud, and we can real-time processing, enable the real-time processing of large data set. And finally, we can use big data analytics for the existing historical data and current data, how to improve the prediction accuracy based on the existing data as well as the current data. Compare with both the historical and the current data, we can give some accuracy or prediction are concerned. Our here we have some output. How to transfer some alert to the people or to the particular the government or state or central government. You can do some. Here we have if I'm going to use the particular technique, means what are the basic benefits I can avail from the existing tool. Benefits accuracy. If you are going to use AI provides, means like you can give the maximum accuracy level. It's more than 95%. We are expecting the AI provide more accurate and timely flood prediction compared to the traditional method. The cost effective compared to the existing method is also it's a cost effective one. And we have scalability in the system we can use for specific across we can use any place or any geographical condition. And we have we can go for some um, uh, current technology as well as the current prediction methods can existing system as well as the new current historical data. Based on the things we can give some specific right accuracy level to the concerned world. Here we have if I'm going to use some the methodology, also some challenges is there. Here we have a data quality and availability and complexity of model and the resource incentive and the ethical occurrence. These are the some little bit drawbacks also is there by using the technology. And you have to avoid some specific process. That means the data and the complexity model and resource incentive like this. Just you can avoid some challenges and can design the our technique. Our model should be the highly accurate one. Here we have some example implementation. How we are going to utilize and how we are going to design the existing based on the AI methodology. The example implementation already having some specific area. Google flood forecasting. Google user use AI to provide high accurate flood forecast in region like India and Pakistan. If they are now they are in the under here they're using some specific area for flood forecasting using AI. Some under process like this, it's not able to implement the 100%. It's like they're having some specific area, some specific tasks are already given. They're under process like this. In the AI model for urban and flood management, here we can give some specific cities or ultra. Here we have some metro cities there. First, we can give some supply to the metro city as well as the secondary city like this. You can go for some smart cities. I think in India there are identified more than 1,100 cities as a specific cities like this. Here we have to implement the particular system. The cities like Singapore are leveraging AI managed to urban flood. In Singapore, they're already they're there are implemented the AI based. That means they're having the big size of uh, uh, rainwater sewage system is there as well as the some flow is there. If it's ahead about some news, if anything happen in It's the rain happened in Singapore. Within a 30 minutes or 1 hour, it's all water should be follow water flow. It's smoothly it's happened, and we can't find any water in outside the area. Read about some news, but maybe yeah, that's why the drainage system, the rainfall model, they are implemented with the AI. Maybe they will manage easily. And artificial insurance companies use AI-based risk assessment. Formally, if we are going to make some claim or something, then here how much the flood it's happened, how we are going to calculate, and we are going how much they already paid, how we are going to return the amount. The calculations is based on the AI suggestions, the data. Yes, formally, before going to conclude, here we have additional system. If you are going to develop the flood prediction management system, means artificial intelligence as well as machine learning. These are the formal phases are included in the particular the new technology. And flood prediction and yearly warning system. First, we have to design the system of flood prediction and yearly warnings. It's before it's going to be happen, we have to give some warnings to alert to the particular people. And flood monitoring detection. For example, if the flood happened, we have to monitor how much of water flow it's happened, how we are going to manage all the things like this. Flood monitoring and detection system should be installed. And flood risk assessment mapping. How much of flood is happen, and how we are going to assess entire flood area, and what will be what happen, how we are going to give some recovery suggestions like this. And flood damage assessments. After flood happen, how we are going to assess entire area, and the economic data, how much they lost their human life or something like this. Here, flood damage assessment and flood control and mitigation. And formally, how we are going to evaluate the entire flood process, flood prediction system management system, and flood response and the resource allocation. For example, in future, what are the things which happen? How we are going to give some suggestions, resources, or some data or existing technology, how you're going to. These are the phases of the new system. If the AI-based flood prediction system, it should be monitor all the aspects. You can have some 100% accuracy and the effective system based on the input like this. Here, finally, here we have some basic models we are going to discuss with the techniques. What are the insight techniques, detailed insights, what are the things are included in the AI-based prediction system. Here, supervised learning model is there. It's based on the historical data. I already discussed about machine learning also is there. Here, we are going to use SVM and AN, and artificial neural network also we are going to use in the supervised model. Unsupervised learning, we are going to observe river flow as well as soil moisture challenge. And deep learning and CNN and RNN also already discussed about the deep learning process. Here, what are the basic data sources we are going to use? Meteorological data, hydrological data, remote sensing, and crowdsourced data, and geospatial data. These are the some data we are going to use to analyze the feature detection process. Meteorological data, rainfall, temperature, and the wind speed. Hydrological, it gives the information about river levels and soil moistures. And remote sensing, satellite images and land and use water levels. And crowdsourced data and social media and community reports during the flood. And geospatial data, discuss about the topography and the land cover, the information about topography and the land cover information about the data. These are the data sources we are going to use and evaluate and predict the end forecasting system. Here, this is the global impact. AI reduce the formally, if you are going to use the existing system AI-based model, means it reduces loss of lives and economic damage. Is our big motto to avoid loss of lives as well as economic damages, by improving the disaster and pre-defense of the response. Here we have our AI-based technical, it's a data-driven policy decision. It's a planning policy decision for urban planning and climate changing mitigation. Formally, if you are going to use the AI, artificial intelligence technology for the flood prediction means, we can go for further uh, uh, loss of we can avoid loss of lives as well as the economic damages. Here, uh, uh, here the case studies we already implemented some things. The Singapore smart cities is there. Some India also they are going to plan, and we have some area that already implemented the uh, flood forecasting management system for the observation, data observation. Here, this is the data mining also we are going to use in this process. Here, database technology, visualization, statistics, and machine learning, and information science, and other disciplines. It's all combined together. It can give some specific new recommendation for the flood prediction system. Here, this is some applications area. Finally, we are in the applications area where we are going to use and AI for flood prediction management system means response and recovery and key areas. We can define some key areas. Yearly warning system. Just we have to give some alert to the people, communities and authority about the potential flood. Here, formally, we can give some alert to all people or some system or the some our management system like this who are going to manage or who is the responsible. We have to give some yearly warning. That is the yearly warning system. A real-time prediction and the flow events. Here we have weather and hydrological forecasting. Just based on the existing weather, we can predict the rainfall and rain flow and the potential flow. Uh, Analyzing the meteorological and hydrological data, we can analyze the data, geographical information as well as the weather forecasting information. All the information we can collect and implement the analyze and give the forecasting river discharge and water level using the AI model. For example, how many centimeters it's rain happen, how much of water we are going to collect, how we are going to travel the water with the river like this. We can predict all the information uh, in the water and hydrological forecasting methods. Here, urban flood management mitigate urban flood caused by the poor drainage and heavy rainfall. For example, if we are going to design any new structure or smart cities, we are the the drainage system is very important. So based on the drainage, heavy the big size or based on the existing rainfall catchment area, we have to design the drainage system. Then we can avoid the uh, flood during the rainfall. And we have predictive analysis and the drainage system performance as well as smart city integration is very important. AI-based planning for green infrastructure absorb the excess rainwater. Formally, we can go for the green infrastructure to absorb the excess water, the rainwater. Here we have disaster and reduction and planning process. Here minimize the flood impact through the strategy planning. How we are going to avoid flood strategy planning uh, to entire people the flood hazard mapping to identify the risk zone and to move the people to one place to another place like this. Disaster management system is there, which has a risk reduction and planning. It's a very important role. Here, agriculture and water resource management is their purpose. Here, protect uh, crops and optimized water use during the floods. For example, if the flood happen means how we are going to utilize the existing water or flood in the current scenario. How we are going to redirect the water to the dams or something agriculture area like this. AI model to predict the crop damage risk. and monitoring water lagging condition using the satellite data. And we have insurance risk assessment is there, evaluate the flood risk and insurance financial planning. We have AI tool for calculating property and crop damage and dynamic pricing for the flood insurance policy, how we are going to allocate and provide money to the damaged people, like damaged item. And we have emergency response and recovery. We support rescue and recovery effort after the flood. After flood happen, how we are going to manage all AI-driven resource allocation for rescue teams. Each and every information should be frequently updated to the concerned team or concerned persons. What will happen and what will be the step like this. You can go for the AI-driven resource allocation, analyzing the satellite and the drone imaginary access the damages, how we are going to calculate the damages and supporting logistic and distributing the relief supplies. These are the important things in the emergency and response recovery, and artificial intelligence is the important role uh, in the emergency response recovery area. Here we have climate change and monitoring, understand the adapt to climate and induce the flood risk. Here the based on the existing data, so the historical data, and we have how we are going to process the current scenario data and collect all the information and the long-term challenges in the flood pattern using AI, identify the region and vulnerable area and the sea level rise, and AI-based policy planning for climate. These are the very important things happen in the climate change and the monitoring system the AI, using AI. Here, infrastructure prediction and support critical infrastructure like bridges and dams and roads. We have to plan for the specific infrastructure for each and every area. Monitoring structural health during the floods and predicting the flood impact on the transportation utilization and planning flood resident designs. These are the things should be followed in the infrastructure area, infrastructure protection area. And finally, here we have education awareness. Here we have empower community with the flood knowledge. We have to educate all our people, like from the childhood to the educated or uneducated people. We have to give some specific information if rain happened, what are the basic need to execute or something, flood something or basic strategy or a simple uh, process steps we have to initiate and educate to all the people to avoid the flood related problem. Here, empower community with the flood knowledge. Application AI powered simulation for educating to flood risk. We can create some specific tools for to all the people, and we have personalized alert to advice through AI-driven app. uh, Sometimes if the rain or some cyclone happen means you have to give some alert or message to the individual people, and social media analysis to identify the community needs during the floods. So formally, how we are going to educate to the information to all level of people. Education awareness is very important. Yeah, these are the some specific areas or to have a vital role the AI driven process, AI driven, and the uh, flood prediction and the management, flood prediction and management system, which having the vital role using artificial intelligence. With this, I would like to conclude my entire session. Do you have any questions? I'm ready to answer some participation queries. Thank you so much for the giving opportunity to share my knowledge to all our people.
Excuse me, sir. This is Seema from Bennett University. Sir, from
Yes.
prediction only, we can know the flood damage because of that, or what are the factors affecting the floods. But technically, what are the other parameters we can evaluate from this machine learning model, sir, for flood prediction and all that?
Yeah, it's normally the flood prediction here. Uh, Nowadays, we are depending upon the historical data only. Normally, it's any cyclone or any rain happens, they're comparing with the existing. That means last year what's happened, or 5 years before what's happened. Here, these are the traditional methodology we are collecting the information. Nowadays, here we have some lot of weather forecasting information also is there, but in the prediction with the data, the current scenario data, how we are going to make our people get awareness. That means with the current technology, we have artificial intelligence, we have machine learning and deep learning, and different technology method is there, and remote sensing and their IoT devices is there. With this device and technology, how we are going to collect the data in and around the environment, and based on the data, we can compare the existing data. We can analyze and predict. Maybe it's going to be happen. You can give some alert to the people, or alert to the particular disasters management system. The people, they will get some awareness, they will, we can avoid some life loss. That's all. For example, if we don't give any information to the people, means it's maybe life loss, it may be 100. If they are given some information, it's maybe reduced. Like, this is the things behind the process, AI based prediction system. You can give some accuracy level, it's like more than 90 plus, yeah, like here I already shared some information. For example, if I'm going to check here tomorrow, what is the tomorrow weather here means, almost 95, 99%. If it is make it tomorrow, it's a rain means it's a rain happen like this. I haven't find in India, it's like such a information. I don't know what's the problem with our data or something, our app. This is the scenario is there, that we have to make some collect information and give some specific alert to the people. This is the main motto behind the AI prediction
Well,
system.
can you tell me from where we can get the authenticated data for this
Yeah,
floods?
here it's all depends upon the satellite information. Yeah, here nowadays weather forecasting is based on our satellite system. Here with the satellite system, we can capture all the yeah, existing remote sensing data is there, and river area, and uh, reservoir area, and based on the climate and which season the rainfall going to be happen, and these are all calculated. It is data is there from the satellite. In the satellite aspects, we have different type of data is there, and how we are going to handle and manage the data. This is the very important one. Here nowadays, there, still the last week the cyclone happened. They're updating every 1 hour or 2 hours, but the the direction will be changed. Normally change, and it's a different phase. Yeah, that's why we have to analyze the data. It's maybe we have to give some different as options like this. Yeah, if it's happened this area, or otherwise it's going to be happen, or otherwise it's going to be happen here, like this we can give in and around the area, means all people they will get awareness or alert. But it's formally, it's last week it's happened there, mentioned only in the Chennai, but all Chennai people they're alert. But it's happened the nearer district, the Viluppuram and the Kadalur district. It's happened in Tamil Nadu. We can see in the uh, news like this. We have to give some specific or particular information to in and around the area, means all people they will get alert, and they will protect themselves. Yeah, farmer. It's all based on the data, how we are going to handle the data from the satellite information. Yeah, that's why we have to use the new techniques or new technology, AI-based methodology, and analyze and evaluate the data, and make some new uh, tool for identifying the specific information.
But sir, practically from where we can get the data? Any websites or any portal where we can find such
No,
data?
no, we can't able to get the system. For example, the individual human being, we are going to make any prediction system. This is for disaster management. Formally, we can give some suggestion to our system, our information like this. These are the techniques are is availability is there. For example, if we are going to use the system means we can use your data, we can analyze, we can give some specific result like this. We can give some suggestion to our states or central government or disaster management system. Yeah, from they can only they implement. Yeah, formally the weather forecasting, our central government they're having some satellite information is there. Just they're given only the result. But we are going to implement the new system means we have to collect the data the proper way, and we can analyze and process and execute the application with the help of is the way. Just we can have some alert and all the information only via website. Yeah, like this. We can't able to get current data. Yeah, that means based on the existing news, they can propagate and they can show some information in the social media or website or something like this. Yeah, but we can have some proper way with the central government. The means we can go for further process. We can identify the specific AI prediction management with the data. Yes, can you hear me?
Yes, sir.
Hello.
Yes, sir. Thank you so much, sir. Thank you. Thank you,
Yes,
sir.
yes,
Yes, sir, we are
yeah.
hearing.
Yes, Mr. Murugan. Do you have any questions, other participant?
Any queries from participants?
Yes, I will share my PPT to
Yes, sir.
Murugan. Okay, uh, we can share the same PPT to all the participants. Okay.
Yes, sir. Thank you, sir. Thank you for a wonderful session, for your valuable input, sir. Thank you.
Yeah, thank you
Any
so
more,
much.
any
Thank
questions are
you.
there? Any questions you can ask him? Thank you, sir. Thank you.
Yeah, thank you so much for the opportunity for the Madanapalli Institute of Technology. Yes, uh, I, I express sincere thanks to the management and ATAL sponsors, Madanapalli Institute of Technology, as well as Department of Cybersecurity. They organized a wonderful FDP on AI solution for water management and smart cities. Okay. Yeah. Once again, I express sincere thanks to all, and thank you so much. Bye.
Thank you, sir.